Happy Wednesday, everyone. My name is Yiling Zhuang. I'm the Water Resources Regional Specialized Agent in University of Florida IFAS Extension for Central Florida region. Welcome to the Water Wednesday. Water Wednesday is a webinar series about Florida's precious resource, water. Every Wednesday afternoon at 2 o'clock Eastern Time, we will live stream a 30-minute talk about Florida's water and what we can do to protect it. We host our webinar series on Zoom and broadcast to Facebook Live. We have attendees joining us all over the states. Please put in the chat box and tell us where you are watching this webinar. If you are viewing it on Facebook, please be aware of the scammers. This webinar series is free. Please do not click any links that are not posted by the admin. We have a theme for every month. Last month, we focused on clean water. If you missed the talks, I will post a link to our recap blogs and recordings in the chat box. This month, we will focus on water conservation. As a start, I will give you a quick overview of Florida's lifeblood, water. So when you hear the phrase Florida's water, what other words or phrases come to your mind? So please put in the chat box and let me know what you think of Florida's water. So while you are typing, and I will move on. So before actually we answer this question, let's just look at where we can find Florida's water. Generally speaking, we can find Florida's water above ground and underground. When it's above ground, we call it surface water. When it's underground, we call it groundwater. So for surface water, we have about a dozen major rivers. They are fairly short. When you add them together, about 10,000 miles in total. In Florida, we also have about 7,800 lakes. And within nearly 8,000 lakes, we have something very unique. It's called coastal dune lakes. These lakes are a very unique geographic feature. The reason we say that it's you can only find them in Madagascar, Australia, New Zealand, and in the States, you can only find them in Oregon state and state of Florida. And even in state of Florida, you cannot find them everywhere. The place you can find it is at the Panhandle. It's called Walton County. So they are usually about a mile or two close to the coastal, and they don't have a fixed structure or shape. It's a mix of fresh water and seawater. So it's a very unique feature. Next time, if you visit Panhandle, I will encourage you to go have a look at those coastal dune lakes. And also, we have vast and diverse freshwater wetlands. And please put in the chat box and let me know what's your favorite wetland. And Florida is three sides surrounded by water. So of course, we also, as surface water, we also have ocean. Within the surface water list, we have temperate ponds. They are very important for birds and for blood protection, for flood protection, excuse me. And we can also find water in soil. So you can see this list go on and on, but those are just some major surface water. In fact, most of Florida's water is found underground, flowing through Swiss cheese rocks and sandy sediments called aquifer. And most of us probably never see it in natural setting. So like this picture, you can see it's in a cave, and the water here is the aquifer, is the groundwater. So we rarely see groundwater in its natural setting, but all of us, most of us, not necessarily all of us, but most of us see groundwater, especially Floridians. I would say more than 90% of Floridians, we see groundwater in that shape. It's when we turn on the faucet. So the water we use for drinking, for bathing, it's from groundwater. And the quality of groundwater and Florida's groundwater, the major aquifer, it's called the Floridan Aquifer. It's among the best aquifers in the nation. So far, I went through the water resources in Florida. So you may wonder, Florida has such rich water resources. So what's the big deal here? So since we are on the Floridan aquifer, let's just look at the water quality here. As I say, generally groundwater quality is good. It's better than surface water. And for Floridan aquifer, it's still one among the best aquifers in the nation. But if we look at the nitrate concentration, it has exceeded the required or the standard for water discharging from springs. And this issue, Florida's water, gets complicated if we look into the future. We put population growth into the consideration. So this map shows the population projection and the land use in 2070. So the 2010 baseline was 18 million people, and is projected by 2070, the population will double, almost double, to 34 million. So population change has consequences for both water quantity and quality. And in terms of water quantity, more people generally means more demand of water. And you can see here, when we look at the increase in population between 1950 and 2010, the corresponding change in total water withdrawal, which is on your right, increased by about 465%, almost sixfold. And with the same study conducted by the 1,000 Friends of Florida, this map shows the projected total demand in gallons per day per acre. And if we took another angle, we look at what does that mean in terms of water demand. It's a little bit different from the time period. It's not a projection to 2070. That's the projection to 2035. So based on this Florida Department of Environmental Protection's annual report, it shows by 2035, Floridians will need an estimated 1.2 billion gallons of additional water per day. It is 18% increase compared to 2015. And this figure here shows the projected water demand by sector. Public water supply, which is the blue line here, and agriculture irrigation, which is the green line here, are the top two water users. They are expected to remain the biggest users in the future. And let's look at an example. This is the water supply planning in Eagle Lake, a city in Central Florida. Water demand exceed the permitted water supply in 2017. This situation is not unique. It is a pattern that we can see in many places across the state. So if you are a water supply manager, what will you do? Will you increase the permitted water supply to meet the water demand, or decrease the water demand to meet current permitted water supply? So while you are thinking what you will do, and I want to introduce another example here. It's called the Central Florida Water Initiative. Like I mentioned, the example of that city in Central Florida is not unique. It's very common all across the state. But when we consider regional water supply plan, it can become more complicated. There are more than one city is involved. Probably it's more than one even more county, like this case here, Central Florida Water Initiative. It was created in 2011. The intent of Central Florida Water Initiative is to implement effective and consistent water resource planning, development, and management throughout the CFWI, which is Central Florida Water Initiative area. From this map, you can see CFWI area consists of 5 counties. So all the part of Orange, Osceola, Seminole, and the Polk counties, and the Southern Lake County. It covers about 5,300 square miles. This area is characterized by 50 local and county governments. The city of Orlando is the largest municipality in the CFWI planning area. However, the residential areas with the largest growth rates are in the north and the south of Orlando along the I-4 corridor. This area supports a large tourist industry and a growing industrial and commercial sector. Agriculture is a significant industry in the CFWI planning area, with the citrus and the cattle as the major commodities. Meanwhile, CFWI covers 3 water management districts. The red line here shows the boundaries of each water management district. So if you are wondering what is water management district, I will post a link here related to Florida water regulations, which gave a quick overview how water is managed in state of Florida and how it's involved. So we go back to this map. Like I mentioned, there are 3 water management districts. So we can already see with that many municipalities, 50 local and the county governments with different industry and with 3 water management districts, it is very important to have a consistent and effective method. And also it's very important to have a collaborative effort among all the stakeholders. So including, like I mentioned, the 3 water management districts, Florida Department of Agriculture and Consumer Sciences, water supply authorities, local government utilities, agriculture and industrial communities, and also environmental groups and interested parties, including residents. So the reason I want to show this example here is just like I mentioned, Eagle Lake, that city, that example is very common across the state. And for this unique region, also face the same issue. Here's the paragraph I got from the 2020 Central Florida Water Initiative Regional Water Supply Plan. So from this, I will just read the slide here. Traditional resources alone cannot meet future water demands or current permitted allocation without resulting in unacceptable impacts to water resources and related ecosystems. And I would like to show this diagram here because this diagram perfectly illustrates the current situation, and it's not just in this region. You can find a lot other places too. So this is the groundwater availability assessment. It indicates the future further development of fresh groundwater withdrawal beyond this is the yellow line here, 760 million gallons per day will triple the minimum flows and the levels within the region. So in other words, the permitted groundwater allocation has already exceeded the groundwater availability. So we need to think different. We need to explore the water conservation options and also investigate more alternative water supply options. And also want to show you this map here, because in Florida, areas do not have sufficient water supplies for the next 20 years are considered water resource caution areas. From this map, we can see most areas in Florida are facing critical water supply issues. So previous I mentioned, I showed the groundwater availability analysis diagram and I said when we don't have enough water, basically two options. One is water conservation, another is alternative water supply. So what is an alternative water supply? So basically anything beyond the traditional water sources is considered an alternative water source. And in Florida, our traditional source of fresh water is groundwater. So just like I said, when you turn on faucet, what you see is groundwater, but just not in its natural setting. So in that concept, anything besides groundwater is considered alternative water supplies in most areas of Florida. Generally, we know water conservation is more cost-effective than alternative water supply. Since 1990, different water conservation projects have saved more than 14 million gallons of water per day. And the water district, the water management districts promote water conservation by increasing public awareness through education, funding programs to replace old water fixtures with more efficient models, working with industry and agriculture to reduce their use of groundwater, and promoting Florida-friendly landscaping, which we can have a pretty landscape, residential landscape, and also without adverse environmental impact. Although conservation can greatly contribute to solving our water supply issues, water conservation alone will not be enough to meet future water demands. We need alternative water sources. So in the next few slides, we will look into each alternative for water supply option. And the first one here is reclaimed water. Reclaimed water is the wastewater that has been treated, at least secondary treatment, and then reused. It is usually delivered in purple pipes. So if in purple pipes in Florida, so if you look around, if you see those purple pipes, then you know your neighborhood is using reclaimed water. And for reclaimed water, you cannot drink it, but you can use it for residential, like landscape irrigation. Up to 50 of water supplied to home is used. Up to 50% of the fresh water supplied to your home is used outdoors for yard. So for this area, use reclaimed water can offset the fresh water demand. Reuse of reclaimed water can also reduce the demand for water from traditional sources by saving potable water for drinking and other daily needs. Rehydration is the way that we apply stormwater or reclaimed water to upland areas or wetland so it can be filtered down to the aquifer. Surface water such as creeks, rivers, and lakes can also be considered as an alternative water supply. In some areas, the surface water is classified as a traditional water supply instead of an alternative water supply. But keep in mind, the surface water is limited by seasonal rainfall. About 60% of Florida's total rainfall occurs between June and September. So during the dry seasons, excessive surface water withdrawals can stress the natural system. So reservoirs are one way to store rainy days waters. During periods of increased rainfall, excess water can be skimmed from surface waters and stored in reservoirs for use during dry seasons. Aquifer storage and recovery is the same concept, but underground. Actual water is injected into aquifer and pumped back out when we need water later. Aquifer storage and recovery systems store water for a longer period of time than reservoirs, eliminate water loss due to evaporation, and reduce the negative impact on land. The last alternative water supply is desalination. There are about 150 desal plants in Florida. As you can see from this map, most of them are located in the coast. One benefit of desalination is that it does not depend on rainfall, but the one downside is that the process is very energy intensive. The desal process also generates high salinity fluid byproduct, which must be disposed of somewhere else. This is why most desalination facilities are at or near existing power plants or large municipal wastewater treatment plants, which can minimize the environmental impacts through the use of existing intake and outflow structure and the blending of desalination brine and power plants heated effluents. So far, the main alternative water supplies are reclaimed water and brackish groundwater. Any water naturally contains dissolved solids in a sufficient concentration that make a surface water or groundwater resource brackish. So the quantification of sufficient way vary. So generally speaking, brackish water is the water that has a greater dissolved solids content than fresh water, but not as much as seawater, which is around 35,000 milligram per liter. So that's the definition. Usually we use that definition to define brackish water. And so far we reviewed what does population mean to water demand or Florida's water in quantity. And then we go back to the same map, the Florida's population future. And then let's look at what does that mean in the terms of water quality. Because we know population change also means a major landscape change. In the last 15 years or so of the 20th century, Florida lost natural and agricultural lands at quite a clip. Most of these lands we converted to urban and other developed areas. And the landscape change in turn means a waterscape change. So what kind of water changes do you think might accompany these kind of landscape changes? So we can look at this map. Here's a Google Earth image of an area of land in southeast Florida. So just glance at that map, you probably already notice a quite contrast in the appearance of the western half or the left half and the right half. So some of you may think I pasted two images together, but actually this is one Google Earth image. So what do you think that water flow and water quality might be different from these two adjacent areas? So the left, it's more like the natural area, and the right, it's a residential area. It's a developed area. So these two adjacent neighborhoods will have very different water stories. One important difference for both water flow and water quality is what happens when we pave over the earth. When rain falls on a natural landscape, which is on the left, so you can see about half of the water infiltrates the ground and nearly half evaporates, and only a small fraction, about 10%, runs off the land into adjacent waterways. And when you look at the right hand, which is an urban landscape, only about 15% of that water can infiltrate into the ground. About 30% evaporates. and almost more than 55% runs across our rooftops, parking lots, and the streets into nearby waterways. So what do you think might be the consequence of high runoff? And one thing, it's we might become more flood prone. And along that way, that runoff water is picking up a lot of stuff. So here, just some examples like sediments, bacteria, fertilizers, pesticides, oil, grease, antifreeze, metals, toxic chemicals, cleaners, litters, and more. So this type of pollution, we call it a non-point source pollution. So which means we cannot pinpoint where's the point. So we know like a wastewater treatment facility, we know that's a point of this particular wastewater. But when it comes to runoff, it comes from different household. So we can now say it's from this household or that household. That's why it's considered a non-point source pollution. And with that, I want to introduce you a new concept here. It's called impaired. So in Florida, a water body, the water quality is too poor for its intended use is considered impaired. So this is the map of here's the maps of waters not meeting water quality standards for their designated uses, covering almost 2,600 water bodies and their segments. Since different segments of the same water body may fail to meet more than one water quality standard. So in total, there are almost 4,600 entrants in the database of the waters not meeting water quality standards, with each entrant being a combination of a pollutant and a water body segment. And most common parameters for which the standards are not met include mercury, pathogens, low oxygen, and nutrients. So when we move on, I also want to bring up another concept, because sometimes we look at water quantity and water quality separately. It just for the just like this presentation when I introduce the Florida's water resources, I introduce in the part of the water quantity and then in the part of water quality. But that doesn't mean they are not connected together. So the map I just showed you, the water quality not meeting their intended uses, actually it's a perfect illustration of how water quantity and water quality are connected. Because we need the right amount of water of the right water quality for the right use. So it's always all together. So just like the watershed, water is connected. The water on my yard is connected to the water on your yard, or probably it's also connected to the neighbor a mile away. Everything is connected to everything else, and everything goes somewhere else. One example, as we use more water, we generate more wastewater, and that wastewater has to go somewhere. For this reason, we need integrated water management, where all water resources are managed as one water. We also have to think about the connections between water use and other resources, such as energy. We need energy to produce and deliver water. And meanwhile, we need water to produce energy. For example, when we use the power generation, we need water as a cooling process. So water and energy are interconnected. When we flip the switch, we turn on the tap. And when we turn on the tap, we also flip the switch. Besides water and energy, we also need to consider food. Water, food, and energy are tightly linked together. Agriculture is the largest water user at a global level, accounting for about 70% of total water withdrawals. The food production and the supply chain accounts for about 30% of the total global energy consumption. There are so many synergies and trade-offs between water and energy use and food production. Any strategy that focuses on one aspect of the food, energy, water, food, energy nexus without considering its interconnections risk serious unintended consequences. So with that, so this presentation, it just want to really make us to think. So let us know what's the current situation, what resources we have in Florida, and what are the challenges. So here's something we might think about going forward. Just some examples here. What are the plans for our future water supply? Or to be more specific, if for each individual, do you know the water supply plan in your region? Or do you live in a water resource caution area? And do you live in a one water community, which means we consider it's a comprehensive management. We don't only focus on one aspect of the issue, we consider the whole synergy. And also, what can we do to help ensure a reliable future water, food, energy supply for people and the ecosystem? And with these questions, I will be happy to answer any questions that you may have. So let me first, while you are typing the questions, let me quickly go back just to check the Facebook, see if we have any comments here. So far, I don't see any questions here. So I would like to post a link as I promised. I will share some link of our previous blog. And the link I just share here is the recap blog of our Florida water regulations. So in that way, you can have a better understanding how water is managed in Florida. And before I let everyone go, I would also like to post a survey link here. So if you like our Water Wednesday series, we will really appreciate if you can take that survey. So just tell us what you have learned from this talk. I see we have some recurring participants here, which is great. I really appreciate your attendance and you like our Water Wednesday series. So you may already notice it's the same survey. We want to use a generic survey to understand how we can improve that. So we will appreciate every time, like after each talk, you can click that link and take that survey. Just tell us what you have learned from this particular Water Wednesday talk and how we can improve that. And with that, I really appreciate your time and hope you can all enjoy the rest of your Wednesday afternoon. And bye now.